This tutorial is brought to you by FreeSWITCH Solutions. Get the FreeSWITCH advantage. Welcome to another tutorial of FreeSWITCH with Fred. My name is Fred Mutesa and I'll be discussing how to configure codecs in FreeSWITCH. If you are in the VoIP world, you cannot do away with codecs. Today I'm going to be telling you, first of all, what a codec is, and then I'll be showing you how to configure these codecs or how to even verify that FreeSWITCH supports a particular codec. By default, some of the codecs are built into the core of FreeSWITCH and you really don't need to do anything more than just enabling it or just using it. But there are some other codecs for which you have to install the modules. For example, G729, there is a licensed version and a free version that of course works in pass-through mode. You can verify if this codec is installed on FreeSWITCH by using commands that I'll show you shortly. In VoIP, codecs are algorithms that serve an important function. They enable the conversion of analog voice signals, that is human voice, into digital packets that can be sent over the internet. They also convert the signals back into uncompressed audio signal for replay. During call setup, there are scenarios that can happen. When the endpoints support different codecs and they need FreeSWITCH to do the transcoding so that we can have two-way audio. To meet the varying demands, FreeSWITCH has several configurable modes of operation as well as runtime variables that can influence how codec negotiation takes place. Typically, the goal should be to reduce transcoding or resampling as much as possible. Transcoding is the case where two sides of the call have different codecs and audio flowing in either directions, which has to be completely decoded and re-encoded to opposite channels format. FreeSWITCH can either validate the codec before the channel even hits the dialplan, or wait until the moment where media is absolutely necessary to perform codec negotiation. This is known as early negotiation or late negotiation respectively. This gives you a chance to decide on a codec from your dialplan logic or even from the result of the separate outgoing call that you intend to bridge. In this illustration, I'm considering a scenario where we have one endpoint, that is Alice, that supports codecs G722 and PCMU. Alice is calling another endpoint, that is Bob, that supports PCMU and PCMA. FreeSWITCH also supports the codecs as listed in the network diagram. During early negotiation mode, when Alice calls Bob, Alice offers two codecs to FreeSWITCH, that is G722 and PCMU, of which FreeSWITCH chooses G722 for its outbound call based on priority set in the FreeSWITCH outbound call list. FreeSWITCH calls Bob and offers G722, G722.1, PCMU, PCMA, and G729. Bob sees the list and chooses PCMU, and FreeSWITCH bridges Alice and Bob. Now, when the call has been bridged, at this stage, FreeSWITCH is transcoding G722 to PCMU because these endpoints are using different codecs. In late negotiation mode with inherit codec set, as I'll show you shortly, when Alice calls Bob and offers its two codecs G722 and PCMU, FreeSWITCH sees the list but does not choose any codec just yet. FreeSWITCH calls Bob and offers this list to Bob. Bob sees the two codecs and chooses PCMU from that list. FreeSWITCH now chooses PCMU on the A leg. After this, FreeSWITCH will bridge Alice to Bob. Alice and Bob are now connected with PCMU to PCMU with no extra transcoding required. That is the biggest difference between early negotiation mode and late negotiation mode. I hope you can differentiate that as I go into showing you where this stuff is done in FreeSWITCH. I will show you where codecs are configured in FreeSWITCH. You can set the codec strings or the codecs that FreeSWITCH will support as global variables, and you define this in the variables configuration file. And then you call these variables under Sophia configuration so that when you start FreeSWITCH, Sophia will look at this configuration and pull in these codecs. You can define the inbound codecs and outbound codecs that FreeSWITCH will support. Let negotiation can be enabled under the C profiles by setting the inbound late negotiation parameter to true. After doing that, you need to you can define the absolute codec string also in the dialplan. So when a call hits the dialplan, FreeSWITCH knows which codecs to use for that particular call. Instead of setting the absolute codec string to the list of codecs, we can set it to a variable EP codec string. This variable is actually set dynamically during a call, whereby FreeSWITCH picks the codecs that were offered by the incoming leg, and then it passes on the same codecs to the outgoing leg. This helps FreeSWITCH not to offer a long list of codecs to the outgoing leg. Alright, on my FreeSWITCH instance, I have set PCMU in my var XML file, both for the global and outbound leg. And then I have set, of course, by default, when you check the internal C profile, you can see how these variables are used in the dialplan or in the C profile as parameters. So you call those variables and set them in the internal profile. I'll demo for you using my Zoiper communicator. I have a registered extension to my instance of FreeSWITCH, and this is how you can set codecs on an endpoint. Of course, different endpoints have different methods of setting codecs. I'll make a demo call and show you in the logs how FreeSWITCH sets the codec. Of course, I'll just receive that this number is not available, but of course, for the early media to be played, FreeSWITCH needs to negotiate a codec, and that is PCMU, which was already set on the system. Thank you for watching. See you in the next video. If you want to advance your knowledge in FreeSWITCH, check out our website for the best training offers, or you can meet us at the ClueCon conference in Illinois, Chicago.